For eons, humanity has looked to the stars in order to better understand the world around them. Recently, it has become more apparent that some things don't work the way they should, the way they think we should, until you consider that there may be more than meets the eye.
Alright.
What?
All the way.
You just get roasted.
Mitch Affrey's a weirdo.
What's wrong?
Well, Calvin, I'm plotting the rotation velocity of a typical spiral galaxy, but instead of the inverse square root relation predicted by Newtonian dynamics, given that all mass is visible, the curve completely plateaus at the galactic center. What gives?
Well, amateur astronomer Mitch, I'm glad you asked. We know from this equation that orbital velocity only depends on a constant, total mass enclosed, and distance from the galactic center. So we can narrow things down a bit. We know the radius is increasing, so for the curve to plateau like that, either our fundamental understanding of the universe must be wrong, or there is a whole lot of mass that we can't see. Now, I don't know about you, but I am fairly fond of Newtonian dynamics at this point. So there must be some kind of hidden mass. We call this hidden mass dark matter.
Wow, dark matter? That sounds so scary. What kind of particle could make up so much of our universe but be totally invisible?
Originally, we thought it was neutrinos, but further tests have shown that based on the average mass of a neutrino, this cannot be the case. Scientists now believe it is some type of particle that only interacts with other matter via gravity. This is called the cold dark matter hypothesis.
Thanks, Calvin. I'm glad there's someone out there who will appear out of nowhere to explain discrepancies in modern cosmology to someone like me with little to no formal training in physics.
No problem, kid. I do it for the people. What's happening, amateur astronomer Mitch?
I'm just doing some n-body simulations of the early universe, but the universe doesn't work like we expect it to, with the stars forming first before galaxies and then clusters of galaxies.
This is a situation where you need dark matter in order for the dark matter to clump up like we can see in the cosmic microwave background, and then form gravitational wells that baryonic matter will fall into, and form the larger structures we know and love.
Wow, I didn't think about it like that. Thanks, Calvin. Thanks, Calvin. I don't know what the world would do without people like you to explain astrophysics to people with little to no physics experience.
I don't know what they would do either, kid.
What's the matter?
What's the matter, you ask? Dark matter. I keep seeing gravitationally lensed light around large superclusters of galaxies. However, for that to be the case, there needs to be 5 to 10 times more mass than I can account for with visible matter.
How can this be the case?
This is another time when we need to invoke dark matter to explain why our observations don't match up with our predictions.
Wow, Calvin, I'm so glad you can come out of nowhere and explain all this cosmological phenomena to me.
You know it. As you can see from the evidence provided, dark matter is needed to account for a lot of the things we observe in the universe around us. But always remember, kids, there might be more than first meets the eye. Originally, we thought it was neutrinos, but further tests have shown that based on the average mass of a neutrino, like